These notes are on solving a 3 by 3 linear system. So a linear system can always be written using matrices. And in order to use matrices, we always have to have our equations in standard form. So I have three equations, that's the 3 part, with each having 3 variables, that's the second 3 part, so 3 by 3. And I can write that as a matrix. The matrix here is written as -6, -4, 1, -3, -1, -3, -5, 3, 6. It's my coefficient matrix times my variable matrix, x, y, z, equals my constant matrix, -20, -8, and -4. Remember, when I multiply matrices, I multiply the row by the column, the row by the column, and the row by the column. So a little side note here, that when I do that, I end up with the matrix -6x minus 4y plus z, -3x minus y minus 3z, -5x plus 3y equals 6, plus 6z. Equals the matrix -20, -8, -4. And in order for 2 matrices to be equal, the components have to be equal, so that means that -6x minus 4y plus z equals -20, -3x minus y minus 3z equals -8, and -5x plus 3y plus 6z equals -4. Which gives us back our original equations. So we know that this matrix setup is equivalent to this 3 by 3 system, because when I multiply this matrix out, I get the 3 by 3 system back. So I want to look at an example with some justification that doesn't involve matrices. Excuse me. So I have an equation here, 3x equals -18, and I want to solve it and fill in the justifications. But I'm going to be really, really specific about the justifications. So the first thing I'm going to do is I'm going to multiply both sides by 1/3. And this is multiplication property of equality, which says that I can multiply both sides of an equation by any value. I'm then going to multiply the 1/3 and the 3, which gets me 1. And I'll simplify that, it's -6. The property that allows me to say that 1/3 times 3 is 1 is the inverse property of multiplication. And then 1 times x is x, and that's the identity property. Of multiplication. Now, when you're solving equations like 3x equals -18, you're often simply going from the first step to the last. You guys have gotten really fast about the undoing the multiplication. You talk about it as division. The reason that I wanted to do this step by step is because when I'm using matrices, we can't divide matrices. But we can talk about the fact that division is the inverse of multiplication, and so that I can rewrite dividing by 3 as multiplying by 1/3. So let's look at how that works when I am talking about matrices. So matrices, we're going to look at the actual matrix, but we're also going to look at how it's represented using this idea of the coefficient matrix times the variable matrix equals the constant matrix, and the justification for each. So just like in the previous problem, I multiplied both sides by 1/3, meaning I multiplied both sides by that I multiplied both sides. So I'm going to multiply this. So this is the multiplication property of equality for matrices. And I'm going to pick a very important value to multiply on both sides. I want to pick the inverse of my coefficient matrix, just like I picked the inverse of 3, the multiplicative inverse was 1/3. So I don't know what that is off the top of my head, so I write it like this. Rewrite my original matrix, my original coefficient matrix, but I want to find the inverse of that. So I write it as the inverse of that matrix. And I have my matrix again. I have my coefficient matrix, x, y, z. And then I'm going to multiply my constant matrix again by the same value I multiplied on the left-hand side. So the -6, -3, -5, -4, -1, 3, 1, -3, 6, but the inverse of that. And let me rewrite this. Sorry, I ran out of space, wrote a little too big. Multiply that by my constant matrix, -20, -8, -4. So I've got here A inverse times my left-hand side and A inverse times my right-hand side. Now, just like in the previous problem, we found that when I multiply a number by its inverse, I get the identity. So if I multiply these two matrices, I get the identity matrix, and the identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. Multiply that with my coefficient matrix. Oh, whoops, sorry. I knew I was confusing myself there. When I multiply my matrix by its inverse, the resulting matrix is this. So by multiplying these two, I get this single matrix. So I have this single identity matrix, so x, y, z. And then on my right-hand side, I still have my inverse matrix, so -6, -4, 1, -3, -1, -3, -5, 3, 6, the inverse, and then I still have my constant matrix, -20, -8, -4. I don't know what this inverse is. It's not like I can just flip it. It's not that it's -1/6 or it's +6 or it's +1/6 as my first element. I don't know what it is, and so I'm going to leave it as that inverse piece for now. So now, when I multiplied my inverse matrix to my matrix, I got the identity matrix, and we call that I. So I have I times x, my coefficient matrix, sorry, my variable matrix, equals my inverse matrix times b. So this is the inverse property of matrix multiplication. And then, just like in the previous problem, when I multiply a matrix by its identity matrix, I get the matrix back. 1 times anything is itself. inverse is still there, so negative 20, negative 8, negative 4. So now I have that my variable matrix X equals the A matrix times the coefficient, the inverse of the coefficient matrix times the constant matrix. And so this is the identity property of matrix multiplication. At this point, it's actually going to be a lot easier to solve this problem using your calculator. There's a way to do it by hand, but it's way more work than it's worth at this point. So I'm going to come over to my calculator. Let me turn the calculator on. I'm going to go back to my original screen, so just the on screen button. And what I need to do is I need to plug this portion of my equation into my calculator. So you'll notice that your calculator has this lovely matrix label on the up above the x to the negative 1 button. So I'm going to press second x to the negative 1. I'm going to use the letters A and B. That's part of why I use the letters A and B here. But I need to edit. So I'm going to go over to edit. My 1 is highlighted, so I'll just press enter. The first thing it's going to ask me is my size. Well, my size is a 3 by 3, so 3, enter 3. And then I enter my numbers. So negative 6, negative 4, 1, negative 3, negative 1, negative 3, negative 5, 3, 6. So I've entered my A matrix. So I need to also enter my B matrix. So I'm going to go back to that matrix screen. So second x to the negative 1. I'm going to edit again, but this time I need to edit a second matrix. I'll edit the B matrix. Right now that matrix is a 2 by 1, but I need it to be a 3 by 1. And now I can put in my constant matrix. So negative 20, negative 8, negative 4. I'm now going to go back to my home screen. So I now need to plug into this home screen A negative, the inverse of matrix A times B. So I go back to the matrix. I want A to the negative power, but I want A. And then I do to the negative 1 power. There's the inverse of A. I go back to matrix again. This time I want B. And now I have on the screen exactly what I'm looking for. X equals A inverse times B. And so I press enter. And there's my solution. So we could say that x equals 2, y equals 2, z equals 0. Or we could say it's the point 2, 2, 0.